Understanding marginal utility is important because it is a component of the rational decision-making model. To see how, consider a simple world where there are only two goods available, X and Y. To maximize utility, individuals must purchase what is best for their happiness given the resources they have. We can determine whether consumption is optimal by looking at two fairly simple conditions. First, the marginal utility of the last unit consumed per dollar spent on that last unit is the same for both of the goods. The condition is represented in the optimality equation, also known as the equimarginal principle. In this formula, mu represents marginal utility of a particular good, and p represents the price of that good. This equation can be extended for more than two products as well, and means an individual is behaving optimally when their bang for the buck from the last unit of each of the goods is the same. The second condition is that all of the individual's income is spent on goods X and Y, and reflects that if consuming more of the goods makes the consumer happier, it cannot be optimal for the consumer to not spend all of their income. Individuals who save most of their money are not behaving optimally because they would be happier if they were using the money on goods instead of saving. Economists attempt to understand consumer behavior to predict how much of a product will sell. The utility maximizing condition can be used to determine how non-optimal consumption should shift in order to increase utility. The utility maximizing condition is MUX divided by PX needs to equal MUY divided by PY. If consumption is not optimal, either the marginal utility per dollar of the last unit of X is greater than the marginal utility per dollar of the last unit of Y, or the term on the right is greater than the term on the left. Utility will increase if consumption is shifted towards the good with the larger term and away from the good with the smaller term. Another way of saying that is that happiness increases when a consumer shifts resources to the good with greater utility. If this consumption shift toward the good with the higher utility is applied when the optimality equation does not hold, the two sides of the equation will eventually come into balance as long as diminishing marginal utility is present. As consumption shifts away from a good, marginal utility per dollar spent increases, and the opposite is true when consumption shifts toward a good. Optimal consumption follows the principle of getting the best bang for the buck, or that consumers use utility to get the most good from each last dollar spent. To see how, consider the example with two goods, X and Y, where the price of X is $2 and the price of Y is $3. The individual has income of $12 that they can spend. If the consumer is acting optimally, she will choose the good that gives the highest marginal utility per dollar until all money is spent. In this case, she will first choose the first unit of X because it gives her the most marginal utility per dollar. She then chooses the good that provides the next highest amount of marginal utility per dollar, the first unit of Y. She proceeds in this manner until all of her income is spent. She is relying on choosing the product with the highest marginal utility per dollar, and marginal utility falls as consumption of that specific product rises. When the marginal utilities per dollar are the same, she's indifferent between X and Y. Luckily, the consumer can afford both of them, so the particular order of choosing has no impact. At this point, the consumer finds that the optimal way for her to spend all of her $12 is to consume 3 units of X at $2 each and 2 units of Y at $3 each. Note that this consumption does in fact satisfy the condition needed for optimality. The marginal utility per dollar of the last unit of each of the goods is equal. A consumer's budget constraint is a representation of the choices between two goods that consumers make based on their limited income. In a simple world with only two goods, the budget constraint can be represented as a line graph. The endpoints of the budget constraint can be found by calculating how much of each of the goods the consumer can afford if all income is spent on that particular good. For example, if the consumer's income is $18 and the price of a book is $6, then the consumer can only afford, at most, 3 books, and the y-axis intercept is 3. Note that points under the budget constraint represent combinations of goods that are affordable but do not exhaust the consumer's entire income. Consumers make choices based on what will bring them the most happiness, and one way this is represented graphically is through indifference curves. An indifference curve shows the utility consumers get from consuming combinations of two goods. Indifference curves can be thought of as level sets of happiness, where each indifference curve represents a particular level of utility. Along any of these curves, the consumer is indifferent among any of the different points on the curve. In other words, the consumer gets the same utility from all of the various combinations of goods X and Y that the curve represents. Indifference curves have a number of features. First, they slope downward for two goods because a decrease in one good must be offset by an increase in the other in order to maintain the same level of utility. Second, indifference curves that are further from the origin represent higher levels of utility, which can be confirmed by the fact that these curves represent greater quantities of goods. Higher levels of utility are represented by the direction of the arrow in the diagram. In this feature, the consumer has a higher utility with both products, and the location of the curves shift to the right. Third, indifference curves bend toward the origin when the good exhibits diminishing marginal utility, which is a situation where, upon buying an increasing amount of the product, the consumer gains less and less utility from it. Fourth, the curves do not cross each other and do not touch. Utility maximization models the consumer as trying to maximize utility within the boundaries of what is affordable. The rational consumer wants to consume on the highest possible indifference curve that they can afford. Therefore, the optimal consumption point is the point where the consumer receives the highest utility but spends all of their income. More generally, the optimal consumption point is located where the budget constraint is tangent to one of the indifference curves. In other words, where the budget constraint touches the indifference curve at only one point. This point of intersection is the combination of two goods that makes the consumer happiest. If the consumer's income increases, their budget constraint shifts to the right. This moves them to a higher indifference curve. Their optimal consumption point is still the point where the consumer receives the highest utility, but it is now on a different and higher indifference curve because the consumer can buy more of both goods.